Have you ever just looked up at the night sky? I mean, really looked at all those countless stars and felt this mix of total wonder and maybe a little bit of dread? The universe is so incredibly ancient and just mind-bogglingly vast. It feels like it should be humming with life, but when we actually listen, all we hear is silence. So let's get into it. Let's explore one of the biggest and frankly most unsettling questions in all of science. If the universe is so big, where is everybody?
You know, the legendary science fiction author Arthur C. Clarke absolutely nailed the stakes with this one. This isn't just some abstract science puzzle. Nope. This is a question that cuts right to the heart of what it means to be human. Are we some kind of lonely cosmic miracle, or are we just one voice in a galactic choir? Either way you slice it, the answer is just staggering to think about.
So let's break it down. Why is this silence so deeply weird? Why does it feel like a paradox? Well, it's because there's this massive, glaring contradiction between what all logic tells us should be out there and what we actually find, which so far is absolutely nothing. And this, my friends, is the famous Fermi Paradox. I mean, think about it. We've got billions of stars just in our own galaxy, and now we know that planets are basically everywhere. The numbers alone suggest the galaxy should be bustling with life. Any civilization even a tiny bit older than ours should have had more than enough time to spread out, to leave something, a probe, a giant solar panel, a radio signal, anything. But we get nothing, just static. Now here's where it gets really interesting. This whole situation flies directly in the face of a huge idea in science called the principle of mediocrity. Ever since Copernicus showed us we weren't the center of the universe, science has been a story of us being, well, not that special. We're on a typical planet, around a typical star, in a typical corner of a typical galaxy. But the Great Silence? It's the first major piece of evidence that whispers, hey, maybe, just maybe, you are special. And that, for a scientist, is a genuinely chilling thought.
All right, so to get a handle on a question this enormous, scientists knew they couldn't just throw their hands up. They needed a tool, a framework to organize all the wild speculation. And what they came up with is a truly brilliant piece of scientific architecture.
Meet the Drake equation. Now, it's super important to understand what this is and what it isn't. It's not some magic formula that spits out the right answer. Frank Drake designed it back in 1961 as a way to structure the conversation, to take one giant, impossible question, how many aliens are out there, and break it down into a series of smaller, slightly less impossible questions. And this table shows you exactly how it works. It's basically a funnel. You start at the top with the astrophysical stuff, the rate of star formation, how many have planets, and thanks to telescopes like Kepler and the Webb, we're getting pretty solid numbers for those. But then, as you go down the funnel, you fall off a cliff into pure, deep uncertainty. How often does life even begin? How often does it become intelligent? And the big one, how long do technological civilizations last before they disappear? We have no earthly idea. So here's the crucial point, the real kicker. For decades, the way we used this equation was kind of flawed. Scientists would plug in their personal best guess for each one of those terms, just a single number, and out would pop a final number of civilizations. This created this totally false sense of certainty, and it usually pointed to a galaxy just jam-packed with aliens, which only made the silence feel even louder and more paradoxical. But what if that whole feeling was just based on a math error? In 2018, a team from Oxford University, Sandberg, Drexler, and Ord, published this incredible paper. And they weren't offering a new exotic solution to the paradox. Instead, they basically argued that the paradox itself might not even be real.
They asked a really powerful question. What if the problem isn't some deep cosmic mystery about why aliens are hiding from us? What if it's just a fundamental mistake in how we've been running the numbers all this time?
And here's the core of their entire argument. The old way used what are called point estimates, single best guesses. It feels precise, but it's really just hiding our ignorance. The new way, their way, uses probability distributions. So instead of guessing one number, they used a whole range of scientifically plausible values for each term, from the most pessimistic to the most wildly optimistic. It's a method that doesn't pretend to have the answers. It puts our profound uncertainty right at the center of the calculation. So what happens when you do that? When you stop pretending you know all the answers and instead you just honestly model your own ignorance? Well, it turns out you get a radically, fundamentally different picture of our place in the cosmos.
They pulled this off using a technique called a Monte Carlo simulation. Okay, think of it like this. The computer basically rolls the dice on the Drake equation millions of times. In each and every run, it randomly picks a value from the plausible range for every single variable. Sometimes it picks an optimistic number, sometimes a pessimistic one, and by doing this over and over and over, it builds a map of which results are common and which ones are incredibly rare. And the results, they were absolutely stunning. When you actually account for all that scientific uncertainty, their model shows there is a 53 to 99.6% chance that we are the only intelligent civilization in the entire Milky Way. Let that sink in. And it gets crazier. They found a 39 to 85% chance we're alone in the entire observable universe. This right here is the mic drop moment of the whole paper. The Fermi Paradox isn't solved, it's dissolved. A quiet, empty-seeming galaxy is no longer some weird anomaly that needs a complicated explanation. According to this model, it's a perfectly normal, statistically likely outcome. We never actually had a good reason to expect a crowded galaxy to begin with. But, okay, let's be fair, this is not the final word. Of course not. Critics point out that when you multiply a bunch of uncertain fractions together, you're probably going to get a small number. Others say, hey, the rare Earth idea isn't new. And the folks at SETI rightly argue that our search for signals has barely even scratched the surface. Plus, and this is really interesting, their own data still shows a tiny but non-zero chance of a galaxy with millions of civilizations. So yeah, the debate is far from over. And we have to remember, the Oxford paper's conclusion that we're just playing rare is just one flavor of solution on a whole menu of fascinating ideas. You've got hypotheses that aliens are intentionally hiding for safety, like in a cosmic dark forest, or that they're so advanced we literally can't comprehend their existence. Or, the really grim one, that all civilizations hit some great filter and self-destruct. The truth is, we just don't know. But let's just follow this thread for a minute. Let's say there's a real substantial chance that we are alone. What does that actually mean for us, right here, right now? This is where the question stops being about astronomy and starts being about philosophy and our own responsibility. First, we have to make a really important distinction. There's loneliness, right? That's a negative feeling, a sense of anxious isolation. But then there's being in solitario, which is just the simple, objective fact of being alone. It's a neutral state that can even be a source of incredible strength and creativity. So if we are alone in the cosmos, which one is it? Well, astrophysicist Howard A. Smith makes this powerful case that being alone doesn't make us insignificant. It does the exact opposite. If consciousness, the ability for the universe to look back and wonder at itself, has only happened once, right here, then we suddenly become the most precious, the most significant thing we know of, anywhere. And that idea, wow, it carries an immense ethical weight. Suddenly, our survival isn't just about us anymore. It's about preserving the only known spark of meaning in the entire galaxy. All our biggest threats, climate change, nuclear war, you name it, they stop being just threats to humanity. They become threats to the universe's only known way of experiencing itself. Our job becomes that of a custodian, a guardian of that fragile flame. So that leaves us with this final, incredibly challenging thought. Maybe the Great Silence isn't a mystery about where everybody else is. Maybe it's a mirror, reflecting our own potential rarity and our profound responsibility. If it turns out that we are the only voice in this vast cosmic silence, what do we have a responsibility to say?